You tonight, Blake?
Alright, so we're gonna like start learning how to graph tomorrow. So our teacher said that we should just get a head start on that. So I have some problems. So it says, sketch the graph of each function and identify the vertex and axis of symmetry.
So we're
The
dealing
problem,
with quadratics. I know that
right.
immediately.
So the problem is y equals 2x squared plus 4x minus 2. And yeah, we have to do that.
Okay. So they want you to graph this.
Mm-hmm.
Well, quadratics, if I were to look at a parent function, which is this function right here, that quadratic would look just like that. Okay?
Mm-hmm.
All right, go on now. Sorry, hold on. Well, if I look at this particular function you gave me, the first thing I notice is I can factor a 2 out.
Mm-hmm.
Oh my goodness, and that's as far as I can go. I cannot factor that anymore. You sure this is the right function?
Let me double check.
Yeah, do please double check it. It would make more sense if it was plus 1 or plus 2.
Yeah, this is it.
It's minus 2 at the end?
Yeah, it's 2x squared plus 4x minus 2.
And they want you to graph that.
Yes, they want us to sketch the graph of each function and identify the vertex and the axis of symmetry.
All right. Well, we can identify the vertex. It's not this function here. We have to do something called completing the square. You heard of that?
No.
Really?
Mm-mm.
What are they doing giving you this problem?
No clue.
In other words, the general format for a quadratic is this. Where h and k are the vertex.
Mm-hmm.
Okay? The vertex, you know what the vertex is, right?
No, not really.
Well, if I have a quadratic that's like this is the vertex.
Okay.
If I have a quadratic like this, that's the vertex. If I have a quadratic like this, that's the vertex. Okay? So they all are called parabolas. So the vertex of a parabola is the bottom of the U.
Mm-hmm.
Now, I don't even know how to deal with this when they're giving you a problem that is beyond what you've told me they've taught you. The only way I know how to do this problem is by completing the square. So that's what I'm going to go with.
Okay.
You're going to get to completing the square fairly soon if you haven't got it yet. So it's not going to hurt you.
Okay.
To complete the square, you isolate gosh. The main thing you're interested in is not to change the function as you go from one line to the other.
Mm-hmm.
Is this function the same as this function?
Yes.
Yeah, it is. Now, I can complete the square inside the parentheses. And the way you do that, oh man, this can't possibly be right, because this is a really difficult completing the square problem. They're not going to give you that kind of a problem at this stage of your education. They're going to give you a simpler one to at least teach you how to do it.
So what is this? Like, problem number 1.
I know, I don't get it. That's why, okay, I can complete the square here. I take half the coefficient and square it, which is 1/4. And then I multiply, I balance out the equation. I just added a half to the equation, so I have to subtract a half. And now I can write it the following way. Now I have it in vertex format, where h is the x-coordinate of the vertex. So h is equal to minus 1/2. And k is the y-coordinate of the vertex. So I've solved for the vertex. Now, that's the most important thing when you're trying to graph something, is once you've solved for the vertex, you know the most important part on that parabola, which is the vertex. If I want to graph that, that's where I start. Well, x is minus 1/2. We'll make that minus 1. And we'll make this minus 2. So h is minus 1/2. K, the y-coordinate, is minus 5/2, which is right there. So that's the vertex. And A is positive, which means it opens up. So I'm looking at a parabola that looks like that. Now, the only thing that is inaccurate about my drawing, this is 100% accurate right there, the vertex. What I'm not sure of are those x-intercepts. So, if I want to solve for those, in other words, in order to accurately graph a parabola, you really need 3 points. You don't just need 2 points, you need 3 points. There's actually a better way to do it than solving for those x-intercepts. This is very complicated. It seems like it's above and beyond what your math level is right now, but I don't have any choice but to explain it to you.
Mm-hmm.
So, the line of symmetry is always the vertical line that goes through the vertex.
Mm-hmm.
Well, the vertical line that goes through the vertex is x equals minus 1/2. That is the equation of that dotted line. Notice that the parabola is perfectly symmetrical about that dotted line. You with me?
Mm-hmm.
All right. Now, there are two different other points that I can choose. In other words, I have to find two other points on this parabola in order to define it as a parabola. The normal way would be to find these x-intercepts, but that involves setting y equal to 0 and solving that quadratic and using the quadratic formula,
Mm-hmm.
which is hard. There's actually an easier method of graphing this, and that is if I can figure out what that point is, well, I know that this thing is symmetrical. Can you figure out what that Y-intercept is?
That would be like negative like 6 maybe.
What's the x value when you're on the Y-intercept? Always, 100% of the time.
0.
Okay, so plug in 0 for x, what do you get for y?
Uh, you would get you would get you would get negative 2.
Correct. So when x is 0, y is negative 2. So that is that point right there. So there's your second point that you need to plot a parabola. But we need a third point. Do we know what this point is right there? In other words, exactly opposite that 0 comma minus 2 is our third point. If we can figure out what that point is, that's all we need to graph it. 3 points determine a parabola. Remember that this is symmetrical. That vertex is at minus 1/2. And we didn't even figure out the y value. Oh, yes, we did. Minus 5/2. So, if this point right here, the vertex, is minus 1/2 comma minus 5/2, what is the x-coordinate of this third point that is symmetrical with that?
Like uh um,
How far away is this dotted line from the y-axis?
negative 2. Or wait, or
It's this far away.
negative 1. Wait.
The equation of that line is x equal minus 1/2.
Right.
So go an equal distance to the left, and you will find its symmetrical point where x equal minus 1. So that symmetrical point, I know, has to be minus 1.
Okay.
Okay? And now, in order to find out what the y value is, plug in minus 1. So we have 2 times minus 1 squared plus 4 times minus 1 minus 2. What is that equal to?
It's -2 squared
Now,
plus.
hold on. Make sure you do your PEMDAS right. First of all, you're going to square -1. What does that equal to?
1.
Multiply it by 2.
2.
Okay, so that thing is equal to 2. What's that
And
equal to?
-4 minus 2.
So that whole thing is -4. So that's what that value is. And there are my 3 points. Here, let me spell it out. Vertex is -1/2 minus 5/2. The Y-intercept, which is this point right here, is 0, comma, -2. And the third point, which is opposite the Y-intercept, is -1, comma, -4. There's your 3 points. That's all you need to graph a parabola. When you have those 3 points, just make dots and draw a parabola through those 3 dots. Now, like I said, this appears to be awfully advanced.
Let me see if this other one.
From what I'm used to working with students in quadratics, that would be a high level of difficulty. And here's the problem I have, Blake, is that's not the best way to tutor math.
Right.
You don't start with the hardest problems. You start with the easy problems. Then you work your way up to the medium problems. And then you do the hardest problems. So don't automatically give me your hardest problem. Give me a problem that you don't know how to do that's easier, because you really don't learn much from a problem like we just did. You just don't. That's just not. It would be like if I was trying. Do you ski?
No.
If I was trying to teach you how to ski, I would not drop you on the expert slopes to start. I would start you on the beginner slopes, let you get good. Then I would move you to the medium slopes and let you get better. And finally, when you got good enough, I might say, let's try an expert slope. Well, it's the same way with anything, regardless of what you're talking about, including math. You don't learn math by starting with your hardest problem. And yet, I get a lot of students that's what they do. When they first start working with me, boy, they give me their hardest problems, which doesn't help them at all. What you want to do is start with the easiest problem that you do not know how to do. And then we'll work our way up. So, do you have any problems that are like that fit that description? And if I get the fact that you're not sure whether it's a hard problem or a medium problem or an easy problem. So go ahead and give me whatever you got. It's just don't start at the bonus problems and work your way down. That's not the way to go.
Okay. Let's see if this one's better than y equals -x squared minus 2x plus 1.
All right. What's the consequences of that negative sign right there in terms of how it affects the shape of our parabola?
It's gonna be on the
Open up or open down?
Open down.
Yeah. It's going to be a parabola, something like this. Okay? So that's the first thing we want to take note, is that it's going to be a parabola that opens down. Now, the question is where is the vertex, and where, if it does, cross the x-axis? Well, first of all, the vertex, the x-coordinate of the vertex is equal to that. Have you been taught that?
No, not yet, but I'll probably learn it tomorrow.
Well, there's lots of different ways to analyze quadratics. To me, when you have a quadratic like this and they ask you to graph it, this is the best way to start, which is to find the x-coordinate of the vertex, which is going to be a vertical dotted line, and that's also going to be the line of symmetry. So in this particular function, what is minus b over 2a? Do you know what a and b are?
Would it be like the
A is the coefficient of the x term. Excuse me. A is the coefficient of the x squared term. B is the coefficient of the x term. So that's B. What's minus B?
That's
If B is minus 2, what is minus B?
I'm confused. Like, so,
Okay.
like,
Here's what we got. B, we know, is that right there.
right.
So what's minus B?
2.
You got it. What's A?
2a. So a is 2.
A, hold on. A is the coefficient of the x squared term. What is the coefficient of the x squared term?
X or wait?
It's minus 1. Never forget that there's always a 1 there.
Mm-hmm.
So the coefficient of the x squared term is minus 1. Multiply it, 2a becomes minus 2. So the x-coordinate of the vertex is minus 1. What does that mean? Well, we go to minus 1. We draw a dotted line. That's the line of symmetry. And our parabola, we know it opens down. The only thing we don't know at this point is where it is. Is it this one? Is it this one? Is it this one? Is it this one? But it's one of those.
Right.
So we have to find the y-coordinate.
Mm-hmm.
So far, the only thing we've found is the x-coordinate and the line of symmetry. Well, to find the y-coordinate, you plug in the x-coordinate into this function, and that'll tell you what the y-coordinate is. In other words, when x equals minus 1, what does y equal? Plug in minus 1 for x.
Alright, so that would be 1, and then that would be
Hold on,
2.
let's do it step by step. When you get a problem that says plug it in, I don't want you to do anything in your head at all. What I want you to do is plug it in. So what I mean by that is we still have that minus sign. We're plugging in minus 1 for x. You see what I'm doing?
Yes.
Minus 2 times minus 1 plus 1. In other words, that should always be your first step. Now let's simplify. Always get rid of your exponents first. What's minus 1 squared?
Positive 1.
Okay, I still got that negative sign there. So that's what that becomes.
Mm-hmm.
What's this become?
That becomes, that would be a positive 2.
Good. And then we got that plus 1. Well, that cancels with that. So y equals 2, which means we're dealing with this parabola right there, where that point is minus 1 comma 2. In other words, we have found the vertex.
Mm-hmm.
Now, the only thing we don't know is the other 2 points. In other words, is it a parabola like my blue graph, or is it a parabola like this, or is it a parabola like this? In other words, we still don't know whether it's skinny or fat.
Mm-hmm.
That's why we have to find the other 2 points. Now, the easiest way to find those other 2 points is not necessarily to find the x-intercepts. It's actually far easier to find the y-intercept. Well, look at that function. Tell me what the y-intercept is. You can see it immediately once you get used to this.
Wait, 2 or
It's always that number.
1?
For one thing, the y-intercept means x is 0, correct?
Mm-hmm.
I mean, you're not on the y-intercept if x isn't 0. So x is always 0 when you're on the y-intercept. So when I plug in 0, it takes out that term, takes out that term. The only term it leaves is that term.
Mm-hmm.
So I know what this point right there is. It's 0, comma 1. So, if that's true, what is this point over here that is symmetrical with that? Remember, this line comes at minus 1, that line of symmetry. So what's the x-coordinate on this other point?
-1?
No, one's right here.
So then 1?
How far away is this line of symmetry from the origin? 1 unit.
1, yeah.
So how far do we have to go to the left of that to get to its symmetrical point?
1 unit.
So what is the x-coordinate?
2.
Minus 2.
Minus 2.
In other words, make sure you get your direction correct. What's the y-coordinate?
It would be 1.
Yeah, it's the same.
Yeah, 1.
Now we have our 3 points. In other words, here, I know this can get a little strange because I got so much scribbling all over the screen, but we'll end it with here, but I want you to understand this. So here's what we have. We have a parabola that has that kind of line of symmetry going through minus 1.
All right.
We know that its vertex is at right there, minus 1 comma 2. In other words, we substituted minus 1 into the function, and we got a y value of 2. Furthermore, we know the y-intercept is right there at plus 1 because that constant is plus 1. So we know that at the very minimum, the parabola looks like that. Now the only third point that we need to calculate is that one right there.
Mm-hmm.
This one is 0, comma 1. So this one over here has to be an equal distance away from that line of symmetry. Well, that line of symmetry is 1 unit away from that y-intercept. So I got to go 1 unit in this direction, which makes the x-coordinate of that point minus 2. Well, the y-coordinate is the same, right? Hadn't changed any, so it's still 1. So there's our 3 points.
Right.
We have the vertex, we have the y-intercept, and we have the point that's symmetrical opposite the y-intercept. And that's all we need to draw that parabola. There's only one parabola that can be drawn through those 3 points. So, when you're looking to graph a parabola, a quadratic, always start with the vertex and then try to find 2 more points. Sometimes those 2 other points are going to be the y-intercept and the point that's symmetrical with it. Sometimes it's going to be the x-intercept. There's going to be 2 of those. And you can always figure out the x-intercept by setting y equal to 0 and solving that quadratic. So there's a couple of ways to find 3 points, but you always need that vertex. So don't ever forget this formula right here. The x-coordinate of the vertex is minus b over 2a. That will always give you the x-coordinate, and you plug in your result into the function to get your y-coordinate. That gives you your vertex. You're 90% home when you get your vertex.
Okay.
Okay? Blake, have a good evening. I will talk to you next time.
Yeah, you too. Have a good day.